Hello everybody, welcome to Dr.K.Liu Maths channel. This question is a UK student asked from UK student who asked me how to do this question. And first, there's three parts of this question. First, for a sequence an, which is a1 equal to root 3 and an plus 1 equal to root 3 plus 1 times an. Therefore, we can find this expression of for an. First, an equal to root 3 plus 1 times an. An actually equal to root 3 plus 1 times an minus 1. And that's square. Again, this an minus 1 is equal to root 3 plus 1. Root 3 plus 1 times an minus 2. That is root 3, okay, root 3 plus 1 to the power 3 times an subscript n minus 1. Inductively, we can get the answer. We can get the answer if it goes down to the a subscript 1. Then the power should be, because the subscript plus the power is equal to n plus 1. You can see that n minus 1, n minus 2 is, which is n equal to n plus 1. And in this case, 2 plus n minus 1 equal to n plus 1. Therefore, in this case, if a subscript 1, then the power should be n. And finally, the answer is root 3 times root 3 plus 1 to the power n. And that's the first part of the answer of the first part. Okay, for the second part, for the bn equal to 1 over root 3 over times root 3 plus 1 to the power n minus root 3 minus 1 to the power n. Explain why bn tends to 1 over root 3 times root 3 plus 1 to the power n when n tends to infinity. In this case, you can see that root 3 minus 1 is less than 1 and greater than 0. And root 3 is roughly is 1.7. Let me check. Yeah, 1.773. And if minus 1, it is 0.73. If to the power n, if n tends to infinity, it actually tends to 0. Therefore, root 3 minus 1 to the power n is 10 to 0. Has n tend to infinity. In this case, bn should tend to only this part, because this part is greater than 1. And to the power n, actually, this part is tend to infinity. And it means that we can negate this part, and the dominator of the bn is this part. Therefore, bn tends to 1 over root 3 times root 3 plus 1 to the power n. That is the solution of this part. Okay, for third part, cn is defined by an over bn. In this case, cn equal to an over bn. Okay, write down the answer of an. An is equal to root 3 times root 3 plus 1 to the power n. And this is 1 over root 3 plus 1 to the power n minus root 3 minus 1 to the power n. Yeah. Okay, and identify the limit of cn. That is limit n tends to infinity. N tends to infinity. Limit n tends to infinity. In this case, we can factorize root 3 plus 1 to the power n outside. For these two parts is 3 times root 3 plus 1 to the power n. For the denominator, we can factorize the root 3 plus 1 to the power n. That means 1 minus root 3 minus 1, root 3 plus 1 to the power n. Okay. We can cancel these two because they are same. Okay. And for n tends to infinity, root 3 minus 1 over root 3 plus 1, which is greater than 0 and less than 1. Therefore, the power of n should be tends to 0. This part is 10 to 0. Therefore, the final answer is 3. That is 1, 2, 3. 3. Yeah. Okay, that is the solution of this part. Okay, I hope guys can enjoy this video. If you found Dr. K.Liu Math channel is useful, please subscribe my channel.